Hi, welcome to my video on the review of rational functions. And as in all reviews, it could be marked as a quiz, so you can give a mark for each question, total up the page of the questions on each page. When you get all the questions answered, add up the total on the bottom of each page and see what score you have out of 34. Then you can change it to I change it to percent to see how well you're doing. Let's start. The review is done in order of the videos that were done. Find each f of x equals 1 over x minus 4 plus 2. The vertical asymptote on this rational function is when your denominator is equal to 0, because you're not allowed or can't have a 0 in your denominator. So that means your vertical asymptote is x equals 4. The horizontal asymptote is, as you look at this question, if x goes to infinity, x minus 4 goes to infinity. So 1 over infinity goes to 0. So that means this function f of x goes to 2, because 0 plus 2 is 2. So the horizontal asymptote is y equals 2. If you have each of those, give yourself a mark each, 2 marks. B, f of x equals 3 over x squared minus 4x minus 5. And we want to find the vertical asymptotes. So what we'll do is we have a quadratic to see if this quadratic is factorable. X squared is made up of x and x. Factors of 5 are 5 and 1. The product is negative 5. The sum is negative 4, so it has to be a negative and a positive. So negative 5 plus 1 is the factorization. Now that the denominator equal to 0, so that means x minus 5 is equal to 0, or x plus 1 is equal to 0. So x is 5, x is negative 1. That's your vertical asymptotes. And your horizontal asymptotes is as x goes to infinity. So this is infinity squared in negative 4 minus infinity. So this is infinity on the bottom, and 3 over infinity. Very large number on the bottom, so 3 over that. So as that goes to infinity or negative infinity, the f of x goes to 0. So y equals 0 is your asymptote. Again, I could put a plus 0 here. So this fraction goes to 0 as x goes to infinity or negative infinity. This fraction goes to 0, so the function goes to 0. So if you have 5 and negative 1, give yourself a mark. 0, give yourself a mark. 2 altogether. Now this one, we have 3x minus 1 over x plus 4. So the vertical asymptote is when you make your denominator 0. So that means x equals negative 2 is your vertical asymptote. And your horizontal asymptote, so let's make this a y, f of x a y. So if we allow the function to go to infinity, so this is 3 times infinity minus 1, so that's neglectable, the minus 1. This is infinity plus 2, which is just infinity. The infinities cancels out, so I get y equals 3. So we got a negative 2 for the vertical, x equals negative 2, y equals 3. Give yourself a mark each. Number 2, find each. So here we have f of x equals negative 1 over x x plus 3. So as x goes to infinity, the f of x approaches what number? So as x goes to infinity, x plus 3 is going to infinity. That means this fraction is getting smaller and smaller and smaller, and that means the f of x is approaching 0. So if you have 0, give yourself a mark. B, f of x equals negative x over x squared plus 1, x minus 4, add on 2. So as x goes to negative infinity, the f of x is approaching what number? Well, let's see, we got negative infinity, so we got negative infinity for the x getting large, and we got negative infinity here minus plus 1, so that's a negative infinity. So this is a negative infinity minus 4, so it's just negative infinity because subtracting 4 is not going to make any difference. That's cancels out, so that's a plus 2. So this is, that's going to infinity, so that's 1 over infinity plus 2. So 1 over infinity goes to 0, and so it will go to 2. So if you have 2, give yourself a mark. And without doing all this right here with negative infinity, this is infinity. Think about infinity and infinity squared, so it's still infinity on the bottom, or negative infinity on the bottom. So it's getting, the denominator is getting larger, so that means your numerator is getting, the fraction, sorry, is getting smaller, approaching 0. So this fraction approaches 0, the function approaches 2. C, f of x equals 2 over negative x minus 1. So we have 2 over, and the negative, let's take the negative out and we get x minus 1. So that means we got a negative 2 all over x minus 1, just another name for this fraction. So I took the negative at the bottom and moved it to the top. So what happens here, let's explain. X minus 1 can't be 0, so if x minus 1 is equal to 0, x is equal to 1. X can't be 1 because it's a vertical asymptote, so we have a vertical asymptote at x equals 1. So as we approach this asymptote on the right, coming in this way, it says as approaches 1, 1 is right here, that's the vertical asymptote. On the right side, what's the function doing? So it's two choices. The function is either coming in here like this, going up toward the vertical asymptote, or it's coming in here and going down. So if you take a value of, say, 2 and plug into this equation, so you got a negative 2 all over 2 minus 1. So negative 2 over 1 is negative 2. So when you have a 2, you have a negative 2. So let's say that point is right there, 2, negative 2. So that means it's coming along here like this, and it's going down towards the asymptote. So that means it's going to, as it approaches on the right this way, it's going to negative infinity. As the closer and closer it gets to 1, closer, the further this goes down, down, down to negative infinity. So if you have a negative infinity, give yourself a mark. And the horizontal asymptote right here is, this is a plus 0. So as x gets larger and larger and larger, this fraction gets smaller and smaller, smaller, closer to 0. So that means the horizontal asymptote is y equals 0. So we got a vertical asymptote, horizontal asymptote. Establishing this point means it goes down. If you had this value, instead of this being negative 2, if it was up here, then it would move this way. Total of your page is out of 9. Okay, let's continue. Find a hole in each. So the hole. So we have the hole. This means we will have a common factor. So x plus 3. X minus 3 is the factorization of the numerator. 2 outside of x minus 3 is the factorization of the denominator. 2 is common. So x minus 3 cancels out, so we get x plus 3 over 2 when you simplify. But we have to take care of what we cancel out, what we're doing. We're canceling x minus 3 equals 0. So we're canceling out x equals 3. So if we take x equals 3 and plug it into the function, so the f of 3 equals 3 plus 3 over 2. 6 over 2 is 3. So the whole is that x is 3 and y is 3, because the f of 3 is the y value. So 3 marks for that. So if you have it factored correctly and you cancel the here is 1 mark. If you establish the value of x where the whole occurs is 3, if you plugged it into the expression and got 6. So there's 3 marks. Let's look at B where the whole is. Again, we got a factor, because if there's a whole, that means there's a common factor. So we take the x out because it's GCF. It gives me x minus 2. And now we're going to factor this expression here. So what we have is, let's see, we got a product. The product is 3 times 4 is 12. The sum is negative 8. So the factors of 12 to give me an 8. So the product is positive and the sum is negative, so it's got to be 2 negatives. So what factors of 12? So 12 is 1 times 12, 2 times 6, and 3 times 4. So it looks like we have a 2 times 6, because the product is positive and the sum is negative, must be 2 negatives. So it's negative 2x minus 6x plus 4. So we took the negative 2 times the negative 6 and moved them in the middle. So that gives us 3x. We're going to take let's factor the x out. Let's do it by grouping. So sorry about that. So I'm taking the x out of these two terms here. So it gives me 3x minus 2. I'm taking a negative. What's common here is 2, but I'm taking the negative out. So I'm taking the negative 2 out of these two. So it gives me 3x minus 2. 3x minus 2 is common, and x minus 2 is left. So we take the 3x minus 2 out, I get an x minus 2 left. If you multiply this by 4, you will get this trinomial. So this factors as 3x minus 2 times x minus 2. And again, x minus 2 is common. Cancel them out, and we get x all over 3x minus 2. And we cancel out x minus 2, so we have to look at x minus 2 is equal to 0. So x is 2. So the whole occurs when, if you cancel out your common factor, you have to let that factor equal to 0 to get where the whole is occurring at x is 2. So you take x is 2 and plug it into this equation. So I'm plugging 2 in here, plugging 2 in here. That gives us 2 all over 6 minus 2, 2 all over 4, which is a half. So the whole is occurring at 2 comma 1/2. And the marking scheme is 3. So if you simplify this, did the factoring simplified to here, you get a mark. If you know that you got 2 and you plugged it in and got the half, then it's 3 marks. 1, 2, 3. Number 4, which graph is correct? So we got 4 different graphs there, but we have, notice this is x minus 2. So if you take the x minus 2 and make it equal to 0, so that means x is 2. So the vertical asymptote, we can't have 2 because 2 makes the denominator 0. So the vertical asymptote is that x equals 2. So that's negative 2? Nope. This is negative 2? Nope. So it has to be one of these. But notice here, they're both going up or they're both going down. Because that's a negative, it means the y, x minus 2 all squared, because it's squared, this is always positive. That means negative 2 over this positive number, negative 1 over this positive number makes the y value negative. So it has to be D. They have to be going down. And so both of them are, if you plugged in values of x like 3 and 4, you get points here. If you plugged in the values of x to be 1 and 0 into this equation, you get points here and here. So both of them go down, so that's the answer. And that's a total of 7 marks for that page. Okay, let's continue. Graph indicating each. So we got the f of x equals 4 over x plus 2 times x minus 3 plus 1. So we want to get, so what we can do is we can make the equation in terms of y, just to, okay, there's the equation in terms of y. So the vertical asymptotes are at x plus 2 is equal to 0, or x minus 3 is equal to 0. So the vertical asymptotes are at negative 2 and 3. So x equals negative 2, vertical asymptote, right there. And that's x equals negative 2, and at 3. X is 3 right here. So it will not, graph will not cut through these vertical asymptotes. So that means something happening over here, something happening in the middle, something happening on these sides. So let's look at the y-intercept. The y-intercept is when you let x equals 0. So you take the equation and you let x equals 0. So y equals, I'm looking at this equation, 4 over, putting the 0 in here. So 0 plus 2 is 2. Putting the 0 here. 0 minus 3 is minus 3 plus 1. So that gives me 4, negative 6. So it's a negative 4 over 6 plus 1. That's negative 2 over 3 plus 1. And 1 is 3 over 3, so that's a 1/3. So when x is 0, y is 1/3. When x is 0, y is 1/3. So that's right here. Right there. This is the x-axis, so y is 1/3. So it's cutting through. That's the y-intercept. There's only one y-intercept. Now what about the x-intercept? The x-intercept is when we let y equals 0. So take this equation and let y equals 0. So 0 equals 4 over x plus 2 times x minus 3 plus 1. So we can move, let's move the that stay. So I'm moving the 1 over here to make it negative, but I just switched the equation around. So that's negative 1 over 1. And I'd rather not have this times the negative. So I like to go, just me, I like to go 1 over negative 1. So when I multiply, I don't want this x squared to be negative, it's positive. So multiply, I get x plus 2 times x minus 3. And 4 times negative 1 is negative 4. FOIL this, x squared minus 3x plus 2x minus 6 plus 4 equals 0. So that's x squared minus x minus 2 equals 0. Quadratic, you can use the quadratic formula, or we can try to factor. Let's see if we can factor it. If we can't factor like this, which is the easy way to do, you got to use your quadratic formula. So we got x and x squared. Factors of 2 are 2 and 1. Product is negative and sum is negative. So it's a negative 2 plus 1. Multiply, negative 2 times 1 is negative 2. And outside is 1, inside is negative 2. So that gives me negative 1. Perfect. So x minus 2 is equal to 0. Or x plus 1 is equal to 0. X is equal to 2. X is equal to negative 1. So that's when y is 0. So x is 2 when y is 0. Or x is negative 1 when y is 0. X is 2 when y is 0. So that's one x-intercept there. And the other one is x is negative 1, y is 0 right there. So it looks like in between, the graph is cutting in here, coming down, and it has to go along by the, so it's doing this, and it's cutting over through here, down through. So the closer and closer you get to 3 on the left, this goes to negative infinity. And the same over here, closer and closer you get to negative 2, it goes down. And what about on each side? So let's take a number. Let's take a number and sub in and see what we get. So this is x and y. So what happens over here? Is it here? It will go towards this vertical asymptote. So is it going this way, coming down here? And how do I know it was? Because what happens is that I didn't work out the horizontal asymptote. So let's look at the horizontal asymptote. This is infinity times infinity, so the bottom is getting very large. So that means this fraction is 4 over a large number. So as this denominator gets larger, this fraction is getting smaller, approaching 0. So y is approaching 1. So y equals 1 is the horizontal asymptote. So the horizontal asymptote is going through here. I went from here down to intercepts. So I should have did the vertical asymptote, horizontal asymptotes, but this, no, not too bad. I went back and got the horizontal asymptote explaining it. Now, what about if we plug in a value of x, which is, say, 4? Let's see what 4 is going to give us. So let's plug 4 into this equation. And I'll work 4 out down here. So I got, this is the equation, I'm putting in 4. So 4 plus 2 is 6. And 4 minus 3 is 1. Plus 1. So that's 4 over 6 plus 1. 2 over 3 plus 1. So 1 and 2/3. So 4 is 1 and 2/3. So 4, there's 1, there's 2. So 1 and 2/3 is about there. So that means this graph is going towards this asymptote as it goes to infinity. The graph is going approaching 1. As it goes towards the 3 on the left side, it's going to infinity. So what happens if we take a negative 3? Take a negative 3, which is here. Will the graph be going this way? Or will it be here going this way? Let's see. Let's try negative 3. So 4 over. Put a negative 3 here. Negative 3 plus 2 is negative 1. Negative 3 minus 3 is negative 6. 4 over 6. And it's the same as here. So it's 1 and 2/3 also. I wrote 1.5. So that's a 2/3. This is 1 and 2/3. So there it is there. So it's doing this. So that's the graph. And if you have 9 marks, if you want to distribute the marks, then if you got your vertical asymptote, you got a mark. If you got your horizontal, you got a mark. If you got your y-intercept, you got a mark. If you got your x-intercept, you do a lot of work, so you can give yourself 2 marks for that one. And if you got the 2 points, you can give yourself 2 marks. And if you drew the graph like this, you give yourself 2 marks, 9 altogether. Okay, let's continue. And we have one more to do. Graph indicating h. F of x equals negative 2x squared plus x plus 1 divided by x plus 1. Notice in this one, the numerator and the denominator, the power here is a quadratic, degree 2. The power here is 1, which is a linear. So this means that if we think about it, this is going to, this is x squared. So if you had infinity, you have infinity squared divided by infinity. So as x goes to infinity, then we could have going to, that's a negative. So this is a negative infinity squared, positive. So we cancel it, we get negative infinity. So as x goes to infinity, y is going to go to negative infinity. But let's look at the asymptotes. So the vertical asymptote here is, let me draw a little arrow, x, when I make x plus 1 equal to 0. So the vertical asymptote is that x equals negative 1, which is right here. So we got the vertical asymptote, x equals -1. Now, in this case, because the numerator has a higher degree, we have what we call an oblique asymptote. The asymptote is going sideways. And the only way we have to divide the denominator into the numerator. And we're also assuming, you got to be careful, that can we factor this so that the x plus 1 is cancelled out? Because if this numerator has a factor of x plus 1, the x plus 1 will cancel out and we'll have a whole at a certain point. So by dividing, we'll see if it's working out, because if we divide x plus 1 into this trinomial and get a zero remainder, that means x plus 1 is a factor. So let's divide. When we divide here, x into -2x squared is -2x. Multiply back, -2x squared, and that's -2x when you multiply by 1. That's a negative, we make it a positive. That's a negative, we make it a positive. So that's a +1, +2, so that's a 3x. Bring down your 1. X into 3x is +3. Multiply back, you get 3x multiplied +3. That's a plus, we make it a minus. That's a plus, we make it a minus. +3 minus 3 cancels out. And this is 1 minus 3 is -2. So, because this remainder is -2, that means that this is not a factor. So that means that the equation y, and I could have wrote the equation in terms of, I could have y equals -2x squared plus x plus 1. I could have wrote the equation in terms of y. So y, if I have the equation in terms of y, I have a divisor of -2x plus 3, and we have -2 is the remainder over the quotient, which is x plus 1. So what happens here, the horizontal asymptote, as x goes to infinity, this fraction goes to 0, so y is going to that. So the oblique asymptote is y equals -2x plus 3. So the oblique asymptote is, I'm going to plot that. There's the y-intercept of 3 right there. And the slope is -2 over 1. So we go down 2, right 1. We go down 2, right 1. So this is the oblique asymptote. And the oblique asymptote is a broken line. It won't pass through this. So I'll use a ruler here and draw this as a broken line. There it is. So the graph, the vertical asymptote is coming up through here. And so we know that we have to get the y-intercepts and x-intercept if you wish, but this graph is either going to be in here, tapering this way towards the oblique asymptote, coming down towards the vertical asymptote. So it's in here and here, or it's out here doing this and out here doing this. Let's see. Let's check the y-intercepts when x equals 0. So if x is equal to 0 in here, I get, put a 0 here and I get a 0, put a 0 here and I get a 0, so I get a 1 on the top. Put a 0 here and I get a 1, so it's y equals 1. So that means x is 0, y is 1. When x is 0, y is 1. So that's your y-intercept right here. That means the graph is in here. So the graph, now let's see what the x-intercepts are going to be. So we have this equation, and we make x-intercepts is when we make y equals 0. So we're going to make y equals 0 here. So 0 equals -2x squared plus x plus 1 all over x plus 1. And if this fraction is equal to 0, that means it's the numerator, that must be 0. So if you make the numerator 0, I'm going to divide by negative. So that's 2x squared minus x minus 1 equals 0. And this hopefully is factorable to make it easier. I got to use the quadratic formula. So what happens? I got a 2x and an x. Factors of 1 are 1 and 1. Product is negative and the sum is negative. So I have a negative 1 plus 1. So multiply, negative 1. Multiply here, 2x squared. Outside is negative 2. Inside is 1. Perfect. So that means 2x plus 1 equals 0. 2x equals negative 1. X is negative a half. So x is negative a half, y is 0. And right here we have x minus 1 equals 0. X is 1. So we have x is 1, y is 0. So plot that. When x is 1, y is 0. Right here. And when x is a negative a half, y is 0 here. So that's getting those. Now you can see that your graph is tapering towards that vertical asymptote, going towards your oblique asymptote like this. So that means we'll check to see where the other one is going to be. So let's check to see. This is negative 1. Let's check with the negative 2 to see what's going to be up here. X is negative 2. Plug that into, let's see, this equation. So I'm going to plug it into right here. So we got a negative 2 squared. And I have x is negative 2 plus 1. All over x is negative 2. So I'm going to simplify. So I'm going to square first, which is 4. Multiply is negative 8 minus 2 plus 1. Simplify, negative 1. So that gives us negative 10. That's a negative 9 on the numerator. Negative 1, so that's a 9. So 2, when x is negative 2, y is 9. When x is negative 2, y is 9. That's way up here. So that means that your graph will do this. And just to make sure that you see it, just bring it down. There's negative 2 gives you 9, so the graph goes towards the vertical asymptote, going towards the oblique asymptote. So that brings the end of this review. We have it marked, and hopefully, give yourself some marks here. Forgot to give yourself some marks. So if you've got the vertical asymptote, if you've got the oblique asymptote here, give yourself two marks, 1 mark. That's 3. Got the vertical asymptote. Vertical asymptote. You got the vertical asymptote, give yourself a mark. You got the oblique asymptote, 2 marks. You got the y-intercept is marked. You got the x-intercept, you get 2 marks. You got this point to verify. And you got the graph drawn, 2 more marks, 9 altogether. So hopefully everything has gone well. And you add up all your pages, all the numbers at the bottom of each page, add 34. Put your total here, divide 34 into this number, get a decimal, move your decimal 2 places to the right, and get your percent. And hopefully everything went well with this unit for you. And that brings us to the end of this unit. If you like the video and the review, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.